Let's continue with chemical nomenclature. For this session, we're going to write chemical formula for ionic compounds. We're going to name ionic compounds based on their chemical formulas. This is again the periodic table of the elements. You would see here the classification whether they are metals, metalloids, or nonmetals. Below are ionic compounds. Based on the periodic table, what type of elements comprise the ionic compounds? Answer: ionic compounds are formed between metals and nonmetals. Example, in NaCl, you have Na, which is a metal, and Cl is a nonmetal. K2O, K is metal, and O is a nonmetal. So, ionic compounds are formed between metals and nonmetals. Question: in naming ionic compounds, are prefixes used to account for the number of atoms of each element in the formula? Answer: prefixes are not used in naming ionic compounds. The number of atoms is implied by the charges of the cation and the anions. It is therefore important to know the charges of the common cations and anions. In naming, just name the cation followed by the name of the anion. You also have some metals that are classified as transition metals. When I say transition metals, they would have different charges. In naming ionic compounds with transition metals, why there are two names for one transition metal? For example, we have COCl2, which is cobaltous chloride, and COCl3, which is cobaltic chloride. Answer: most transition metals can exist in more than one ionic form. Thus, it is important to know the charge of the cations in the compounds. For instance, CO in COCl2 has a charge of positive 2, while in COCl3, CO has a charge of positive 3. CO2 plus is cobaltous, while CO3 plus is cobaltic. These are some of the common symbols of the cation derived from the different transition metals. And you also see here the name in terms of the old system and the stock system. So a while ago, we were able to use the old system for cobalt, which is cobaltous and cobaltic. In the stock system, we just named that as cobalt plus the charge of the cation. So for cobaltous, the charge of the cation is 2 plus, so therefore that is named as cobalt 2. For cobaltic, the charge is positive 3, so therefore we name that one as cobalt 3. Ionic compounds, these are compounds formed between metals and nonmetals. Now, how do we name them? First step, you have to write the name of the cation first and then followed by the name of the anion. Second, unlike binary covalent compounds, prefixes are not used to indicate the number of ions present in the formula. For example, you have KBr, so that is composed of K plus, which is potassium ion, and Br minus, which is bromide ion. So we just combine the name of the cation and the anion. So this is potassium bromide. So KBr is potassium bromide. Now here's the list of the common cations. So you have to at least memorize these common cations. So you have the cations for group 1, which are all positive 1, group 2, which are all positive 2. You have group 13, which is Al3 plus, and then you have group 11 for silver. You also have group 12 for zinc 2 plus, and Cd2 plus or cadmium 2 plus, and the polyatomic cation ammonium ion. You also have some common monoatomic ions like group 15, which is negative 3 in charge, group 16, which is negative 2 in charge, and group 17, which is negative 1. So again, you have to remember these common cations and anions. Aside from the monoatomic ions, you also have polyatomic anions. So you have again to be familiar with the names of these anions. So you really have to practice naming so you get familiar with the names. Number 3. Most transition metals can exist in more than one ionic form. Thus, it is important to know the charge of the cation in their compounds. For example, if you have SnCl4, you have SN4 plus and Cl minus. So SN4 plus in the stock system is tin4, while in the old system that is stannic, while Cl minus is chloride ion. So therefore, we name SnCl4 as tin4 chloride or stannic chloride. Either of the two would be accepted. While for SnCl2, you have SN2 plus and Cl minus. So we name this as tin2 chloride or stannous chloride. So again, here are the list of the metals, transition metals with different charges. So you have to be familiar with the names in the old system as well as in the stock system. Some ionic compounds form crystals that would contain a certain proportion of water molecules apart from the ions of the compound. Such compounds are called hydrates. Hydrates are named just like other ionic compound, except for the addition of the word hydrate with the Greek prefix indicating the number of water molecules per unit of the ionic compound. Example, if you have the formula Na2CO3 10H2O. So you name that one by using the name of the cation, which is sodium ion, and the name of the polyatomic anion, which is carbonate ion. So you simply combine the two, so that becomes sodium carbonate. But you have to add the word hydrate with the prefix denoting the number of the water molecules. So in this case, we have 10 water molecules. 10 in Greek prefix is deca. So therefore, the prefix for the word hydrate is deca. So we name Na2CO3 10H2O as sodium carbonate decahydrate. Now, in writing formulas of ionic compounds, example sodium oxide, the first step is to write the symbol of the cation first, followed by the symbol of the anion. So in this case, you have sodium oxide. So sodium oxide, sodium is Na and oxide pertains to oxygen. You have to write the charge of each ion over the symbol of that ion. Sodium belongs to group 1, so that is positive 1, while oxygen or oxide belongs to group 16, which is negative 2. Third step, you have to choose a subscript that would make the net charge 0. The common practice is to make use of the crossover technique, which is the superscript of the cation would become subscript of the anion, while the superscript of the anion would become the subscript of the cation. So in this case, sodium oxide will become Na2O1. Now, if the subscript is 1, we do not denote that 1. So we simply delete that 1. It is implied that if there is no subscript, the value is 1. So Na2O1 is simply Na2O. Now, when both subscripts in the formula can be divided by the same number to simplify the formula, you should do so, unless you know that the actual formula represented. Example, if you have Na2O2, that is for sodium peroxide, you don't divide it anymore because you already know that sodium peroxide would have that formula. So if you have, for example, magnesium sulfide, so magnesium is Mg2 plus, sulfide is S2 minus. So you use the crossover technique, that would become Mg2S2. But you can divide this by 2, so therefore that would become Mgs. The same is true for barium sulfate. So that is divisible by 2, so therefore it becomes BaSO4. And then you also have for hydrates, you follow the same steps, then add a center dot, followed by the number of water molecules indicated by the prefix, and the chemical formula for water. Example, if you have magnesium sulfate heptahydrate, so magnesium is Mg2 plus, sulfate is SO42 minus, and then hepta would pertain to 7. So you have MgSO4, you have a center dot, and then 7H2O as formula for magnesium sulfate heptahydrate. So in this lesson, we're able to write chemical formula for ionic compounds, and we're able to name ionic compounds based on their chemical formulas.